Good evening. My name is Ben Miller. I'm a pharmacist. I've been working for over 22 years. I've done retail. I work hospital. And today I just want to go over some pharmacy calculations. We'll do some alligation method problems. You'll see these problems on NAPLEX in real life, on the PTCB, and they're pretty easy. The more you do, the better you'll get at it. If you don't do it for a while, you forget, but just keep practicing, and they're not so hard. So let's do question one. Question one is we have a 75% stock solution of alcohol. We have a 10% stock solution of alcohol, and we want to make 30%, 1,000 ml, 1 liter of 30%. So in this alligation method, what we're going to do is we're going to do the higher number on top. So here that's 75%. The lower number is going to be on the bottom. That's 10%. And what we want to make, the 30% that goes in the middle. Okay. Okay. So here, 30 minus 75 is 45. 10 from 30 is 20. And what we're going to do is we're going to take these two numerators, we're going to add them up and get a denominator which is going to be 65, because 20 plus 45 is 65. And then you're going to multiply it by the quantity that the order is written for. So in this case, it's 1,000 milliliters, so we're going to multiply it by 1,000 milliliters. And now we're just going to do the calculation. Okay, so we have 20 divided by 65 times 1,000. And we're going to round to the nearest hundredth. So here we get 307.69 milliliters. And then we're going to do 45 divided by 65 times 1,000. And that's going to give us 692.31 milliliters. So we're going to need 307.69 milliliters of the 75%, and we're going to need 692.31 milliliters of the 10%. And when you mix that quantity together of these two percentages, you're going to get a liter of 30%. I think you just have to keep practicing. The more we practice, the easier it'll get. So let's just go into another problem. Okay. So in this problem, we have a stock solution of 75% alcohol, a stock solution of 15%, and the order is written for 35%. And they want a quantity of 400 milliliters. So again, we're going to do the 75 on top, the lower percentage here on the bottom, 15. We want to make 35%, so that's going to go in the middle. And then again, we just do this X. Okay. So we're going to do 35 subtracted from 75. And we're going to do 40. And then we're going to do 35. 15 subtracted from 35, which is 20. Okay. And then again, we're going to add the numerators to give us the denominator. So 60, 60. This time we're going to multiply it by 400 because we need a total of 400. So we're just going to multiply this by 400. 400. Okay. So 20 divided by 60 is equal to times 400 is equal to 133.33. And then we're going to do 40 divided by 60 times 400 is equal to 266.66. So basically what we need is 100, and this is milliliters. So we need 133.33 ml of the 75%, and we need 266.66 of the 15% to give us 35%. And that's going to give us 400 milliliters of 35%. And these two numbers always have to equal the total. So 133.33 and 266.66 has to equal 400. Let's just keep on working, since we're in a flow, let's just keep on doing some more problems. Okay, so now let's work with some dextrose. So in the hospital we use dextrose, and we have stock solutions of 70%, and we have stock solutions of 20%. And you may see it as D70W or D20W. Okay, D for dextrose, 70%. D for dextrose, 20%. And it actually happened, you know, there are times that we have shortages and we're out of 50% dextrose, and they use it when the sugar goes down, especially diabetics, and they want to bring that glucose level back up. They shoot you up with 50 ml of dextrose. And there was a time where we had a shortage, we didn't have any, so we had to make, we pre-filled syringes with 50 ml of the 50% dextrose, and this is how we did it. So we want to make 50%. We only have a stock solution of 70% and 20%. So again, the higher number goes on the top, the lower number goes on the bottom. And 20 from 50 is 30. 50 from 70 is 20. And what we do is we add the two numerators to get the denominator. So 30 plus 20 is 50. 50. And we want to make a liter of this stuff, because what we did was we made a liter bag, and from the liter bag we just withdrew syringes of 50. So we'll do times 1,000. So just to review, we have a stock solution of 70, a stock solution of 20. We want to make 50%, and we want to make 1,000 ml of 50%. So we're just going to do the calculations. We're going to do 30 divided by 50 times 1,000, and that's 600 milliliters. And then we're going to do 20 divided by 50 times 1,000. That's 400 milliliters. Okay, so what we need is, to get this 50% concentration, we need 600 ml of 70%. We need 400 ml of 20%, and that's going to give us 1,000 ml, 1 liter of 50%. And of course, these numbers always have to equal to the total volume that you're making. So if we're making a liter bag, 600 plus 400 is equal to 2,000 ml, which is 1 liter. Okay, so I think let's try to do two more problems, and then we'll call it a night. Okay, so sometimes due to manufacturer shortages, we're out of certain RB bags that we need for the patients, and sometimes we have to make them. So there was a case where 10% and 20% dextrose solutions are used a lot. And obviously 5% is the most commonly used because most of the drugs go into either 5% D5W dextrose or 0.9% normal saline. So there was a case where we needed to make a whole bunch of dextrose 20% because it was out of stock. And so we had the 70% in stock, and we had like 3,000 milliliters of 70%. And then also the sterile water for injection bags. We have also 3,000 ml bags. And we have these empty 1,000 ml bags, these liter bags. So we would just make a whole bunch of liter bags. So in this case, this is like a little twist to the alligation problems that we've been doing because we're going to use sterile water for injection. So then you're probably thinking, so what percentage do we apply to sterile water for injection? So the answer is 0. So let's say we have 70% dextrose solution, and we have sterile water for injection, and that gets a 0. And we want to make 20%. So 70 minus 20 is 50. 0 from 20 is 20. So now what we're going to do is we're going to add the two numerators to get the denominator. So 20 over 70, 50 over 70, and we're going to multiply it by 1,000 because we want a liter bag. Okay. So we're going to do 20 divided by 70 is equal to 0.285. We're going to multiply it by 1,000. And that's going to give us 285.71 milliliters. And then we're going to do 50 divided by 70, multiplied by 1,000. That's going to be 714.29 milliliters. We're rounding off to the nearest hundredth. So you need 285.71 milliliters of the 70% dextrose, and we need 714.29 milliliters of the sterile water for injection. And we combine that together in an empty bag. That's going to give us 20% dextrose solution. If you just to quickly review it again, we had dextrose 70%, we had sterile water for injection, which gets us 0, and we want to make 20%, so we subtracted 20 from 70, gave us 50. 0 minus 20 gives us still 20, and then to get the denominator, we add these two numerators over here, 20 plus 50 to give us 70, and then we do 20 divided by 70 by 1,000, which gives us 285.71 milliliters. And then 50 divided by 70 times 1,000 gives us 714.29 milliliters. And remember, these two always have to equal the total of the volume that you want. So we want 1,000, so these two have to equal to 1,000. I think that's a wrap for tonight. I think we're going to just keep on doing some more of these problems over the next couple nights. And if you have any questions, just shoot me an email, and I'll do my best to answer them. All right, thank you. Have a good night.